Hello, hey, this is Dr. Tech recording something over the super long break because I think not having any contact time within 2 weeks is probably not a very good idea. So this recording is for my cisp300 class, which is particularly in a bad spot because it's a second 8-week class to begin with. So losing basically 2 weeks of time is going to be a big impact. So the first thing I want to do is to answer some of the questions that I got by email. One question was particularly about pre and post conditions. So the situation is like this. We have line 1, having x get x plus x, and then line 2 is z gets x minus 1. Okay, so let's go ahead and figure out, how to compute the pre and post conditions of this thing. Now I can make it so that pre 1 is just true, which means we don't assume anything we know about x or z. That is not going to be very helpful because it's just not going to demonstrate anything here. So it is much more helpful if we make certain assumptions about x. And the easiest assumption is just that x has some particular value of k, which we don't need to specify. We just say that, yep, it has some value of k. And we can also assume, z has some value of, let's say, j in this case. Then we have something to talk about. So once we have these assumptions, the post condition of line 1, doesn't really depend on what exactly is in pre 1. But it does depend on, or the derivation, okay, I should say the derivation of post 1 based on pre 1 does not really depend on what pre 1 really is, because it all has to do with the right hand side of the assignment statement. In other words, we look at the right hand side and say, if I turn it into a function of x in this case, does it have an inverse? So let's check it out. So we'll say f of x is x plus x. In other words, we turn the right hand side of line 1 into a function and we call it f. And we ask, well, what is that? Well, it really is the same thing as 2 times x. So that means we do have an inverse because I'm using f prime as the inverse of f because I can't really write superscript -1 easily with a text editor, but that's okay. So we'll say f prime of the inverse function of f applied to x is x divided by 2, okay? Because if you double x, then the way to undo that is to divide it by 2. All right, so it does exist. So we write down the reasoning here. We say, f inverse x is for the right hand side of line 1. Okay, this is the rationale, and as a result we use the substitution rule. So now when we specify the utilization of the substitution rule, then we say post 1 is the result of the application of the substitution rule based on pre 1, and then we replace every occurrence of x, which refers to the variable on the left hand side of the assignment. So this x is the same as that x over there, and we replace that with the inverse of f applied to x. So basically we're undoing what line 1 is doing to x so that we can reestablish the same relationships as before. So the next step, if I were to make it very step by step, is really just to say, okay, but what exactly is pre 1? So because I'm using an editor, I can do this. I can just copy and paste the entire pre 1, and we substitute x with the inverse of x. So once again, I can also do a copy and paste in this case. So we copy over here, and it's always helpful to use parentheses around it just in case we have operator priority issues here. So now we perform the actual substitution. So x equals k does mention x, so let's replace that x with x divided by 2 equals k. And z equals j does not has anything to do with x, so it remains exactly as is. So that becomes the post condition of line 1. And then we say, okay, now we need to move on to line 2. So we say pre 2 is post 1, and then we also have to explain that because line 2 is sequential to line 1. It is right after that. So we can say line 1 and line 2 are sequential, which is not always the case, because when we have conditional statements or loops, just because two lines are next to each other does not mean they are sequential to each other. All right, so based on that, now we have the same kind of question. This time we have, let's pick a different letter for this function. We say g of z, which is the right-hand side of the assignment statement on line 2. It is x minus 1, so we just write it down, okay? It's x minus 1. But because the right-hand side does not mention anything about the left-hand side, so it has no inverse. As a result, we use the forget rule. So when we apply the forget rule, then what we are doing is we derive the post condition of line 3 to be the result of a forget operation. And the forget operation is to forget everything in, oops, not post 3, it's post 2, is the result of the forget operation based on everything in pre-2. And the things that we need to forget about are things that mention z. So that's how we specify that. But we also know that at this point, after the assignment statement, we also know that z equals to x minus 1 is going to be true. So that's why we attach the conjunction like that. And then the next stage is to expand what is pre-2. So in this case, I'm just going to copy and paste pre-2, which is this entire thing here. So we'll copy this whole thing and paste it here, like so. And then we actually perform the forget operation. So when we perform the forget operation, we can see that this condition does mention z, so it is gone. So now we only have x divided by 2 equals k left. But at the same time, we also get z equals x minus 1. Okay, just like that. So that pretty much concludes the derivation of post 2 based on these two lines of program, of pseudocode. Excuse me. One more time. All right. So there's one more thing that I kind of want to mention here. If you know that k is really just a constant and it doesn't really change over time, it really, really helps, okay, to re-express everything in terms of the constant. So that means instead of saying z equals 2, because now we know x is 2k, so instead of mentioning that z is x minus 1, it helps to mention that it is 2k minus 1. The reason why it's useful to attach constants to relationships or comparisons is because if we make any further changes to x down the line, that makes z isolated from any further changes to x. So to illustrate that point, let me just add one more line here. Okay, so we'll change x here. So we'll change x so that x gets x plus 1. So on line 3, okay, so the same deal here. So we say pre-3 is post 2 because lines 2 and 3 are sequential. So in this case, it's letter h. So we'll say h of x is x plus 1. So h prime of x is x minus 1 is the inverse function. And because we do have an inverse function, we use the substitution rule. And then we use it when we use the substitution rule. Then we say post 3 equals to the result of the substitution operation performed on pre-3, and we're substituting every single occurrence of x with h prime of x. So so once again, I just do a copy and paste here. So post 2 or pre-3 is this expression here. So I just copy over here. And then h prime of x is x minus 1. So now we perform the actual substitution. So now we have x minus 1 equals to 2k, and z equals to 2k minus 1. And you can see already, how the expression of z does not depend on x anymore, which is really handy. But I can show you one more thing later on line 4 that can truly justify why we want to propagate constants as far as we can, so that we express the relationship between variables as much as possible with constants. So in this case, we'll do a little bit of algebra trick and just say that x is 2k plus 1 and z equals to 2k minus 1. Okay, so not too difficult. But now, if I just add one more line here, and so just say for some strange reason we are resetting x to 0. Okay, so what is going to happen here? So g h I j k l m n o. I'm just counting the letters to find a good letter for the function, and we don't really get something that's really particularly useful. I'm just going to pick q, okay? So q of x is 0, has no inverse, okay? Because it maps every single value of x to the value of 0, so there's no way to go from 0 back to what x used to be. Okay, so we use the forget rule. So we kind of know how this works now. So we say pre-4 equals to post-3 because lines 3 and 4 are sequential. And then we say post-4 is the result of a forget operation, and based on pre-4, and everything that mentions x we have to forget. And after this, x equals to 0. We know that too. And then we just expand what we know about pre-4, which is post-3. So we now copy this entire thing over here, and I mention x because that's the variable that we need to forget about. And after we perform the forget operation, we can see that we only lose one term instead of two, because we just lose this one term here, but the other term does not mention x anymore because we performed this additional step here. So if we did not perform that additional step, we would still be expressing z in terms of x, but because we performed the additional step of changing that to only refer to constants that do not change, that means we don't have to forget the relationship between z and 2k minus 1 anymore. So now we have z equals 2k minus 1 and x equal to 0. So if we did not perform this expansion, in other words, if we do not perform this step here, mechanically it's still correct, but in the end we would have lost one more thing that we should have known, which is z equals to 2k minus 1 as a part of the post condition of line 4. So that's kind of a good quick rundown of an example of how to use pre and post conditions. So I hope you are getting this part just fine. And then the next thing we kind of need to know is what are we going to do with the rest of the semester, because there's not really a whole lot of days left. We got about 2 weeks after Thanksgiving, so assuming air quality is getting better after that, we don't really have a whole lot of time left. Let me see, I'm going to pull up a calendar. Okay, let me see if this works. Okay, so let's see. I think I have a calendar that I can access from here, so I can show you that. Let's see. Calendar. There we go. Okay, excellent. So you can see after the 26th, we have the 3rd, we have the 10th as regular days. So we got 2 weeks after that. and we have to go over all the materials that we are supposed to go over so that you'll be ready for cisp360. So this is not really a question of your grade, it is really a question of are you going to be ready for cisp360? So what I have decided to do is I will continue to teach this class using YouTube. Okay, just kind of on and off. I can't really decide how much time I can spend to make new video clips, but we'll just try to do this as much as possible. And then the tests would be something that's a little bit different. I haven't really quite decided yet on the scope of the final exam. We kind of know what the second exam is going to have. It will have everything after the first exam, but also include pre and post conditions, and then all the way up to, but excluding subroutines. All right. So let's go to this class, okay, because I do have all the links already put into Canvas, especially when it's about subroutines. Types and records we may not be able to get to, but that's probably okay as long as we can go over everything in pre and post conditions. So last time when we met, we were still at local variables and parameters. So we'll go ahead and open this. And if I remember correctly, we talked about local variables, and so the next topic is to talk about parameters. I can read all of this, okay, or you can just read it, and I will basically show you examples on the fly, and hopefully that will help kind of speed up the process. So I'm assuming that you guys will be reading, section 3, okay, and it has its own trace and stuff like that. But I think it's better if I perform the trace myself, and you can actually see, how it goes as we do it. Okay, so what we'll do is we're gonna use an example. And I'm starting up LibreOffice Calc. Resize it to fit the screen recorded area. All right, there we go. So we'll go ahead and write this program using parameters. So we'll first define the subroutine. Okay, define sub. It doesn't really matter what the name is, but let's call it sub1. Okay, subroutine 1. We know what a local is, a local variable. So just to show the contrast between the two, we'll just make this program really, really simple. Okay. And we'll contrast a global variable to a local variable to a parameter. Okay, so now we say by value, or just by val. This is a parameter, so we'll use a name that reflects that. I'll call it param1. So param1 is the name of the parameter, and this is the only one. We have a local variable. We'll call it local var1. And in the subroutine, we'll say local var1 gets the value of param1 plus 2, and then we have a global variable, global var1, which gets 2 times the value of local var1, and defines sub. Okay. So this is the definition of the subroutine with only these 4 lines. Doesn't do anything particularly useful, but it does help illustrate the concept. So on the outside here, we'll just say that we have one single invoke to sub1. Okay, that's my entire program. We'll use the row number as line number because they are lined up already. So now we can open up a new window for tracing. So there we go. All right, and of course we want this one to show the code, and we want the second one to show the trace. So when we're tracing, once again we need line number, In this case, there's no need for comments because we don't have any we don't have any conditions to evaluate. So the first thing we notice is, do we have any global variables? Because any type of global variables need to have a column pre-allocated before we even trace the first line of code. So in this case, let's look through all the names. We have local var1, which is a local variable. It doesn't exist until the subroutine is invoked. We have param1, which is a by-val parameter. And we'll learn also that a parameter is kind of like a local variable with only one kind of minor change. So because it is like a local variable, param1 also does not exist until the subroutine sub1 is invoked, which means we don't allocate a column for it automatically. But we do have global var1, which is not a parameter, and it is also not a local variable. That makes it a global variable. So that means we have to pre-allocate for global variable 1, global var1, as a pre-allocated column. So here's my precondition, and we assume that we don't know anything about that, about global var1, and that's my precondition. We start execution on the first line that is outside of the definition of a subroutine, which is line 7. So on line 7, we do the usual thing. We allocate a column for the return line number. And in this case, because there's no more pseudocode to execute after line 7, we still say that, well, we're going to go back. But when we do go back, it is the post line, which means we are done. So that part we kind of know already. This is common to every single subroutine. So we also know about local variables. They are allocated as we get into a subroutine. So that means local var1 is allocated here. And you might ask, but why am I leaving column D as a gap in between? Well, I think you probably guessed it already, because earlier I said a parameter is like a local variable, except for certain things. So that's why I'm skipping column D, because column D is actually for param1. Now the ordering between column D and column E, which one uses the left column and which one uses the right column, is not really particularly important in this class, but in assembly it becomes kind of important. But in this class we just kind of go like, yeah, either way is fine. Okay, so the one thing that is different about param1 is the value has to be specified by the caller. So that means when I invoke sub1, this is actually not sufficient because I am not specifying what value goes into param1. So if you have parameters, you always have to specify the caller the invocation statement has to specify the value of the parameter. So in this case, I have to specify, let's say 23, okay? And then I use a right arrow to param1 to indicate the information flows from 23 to param1. So now it starts to make sense because now param1 has an initial value of 23 because it is specified by the invocation on line 7. So the initial value of a parameter, of a by-val parameter, is specified by the invocation statement, as opposed to a local variable which always starts with an unknown value. All right, so once we get into the subroutine, we kind of know what's going on here. Local var1 is param1 plus 2, okay? So param1 is 23, 23 plus 2 is 25. So local var1 is updated to 25 here. And then on the next line, on line 5, the global variable is updated. Global var1 is 2 times local var1, which is 2 times 25, and that makes it 50. So we update global var1 to 50 here. And then we get to line 6, which is the end of the subroutine. There are a few things we need to do. The first thing is common to every single subroutine. We look up the rightmost return line number column, which in this case is column C. It tells us to go back to post. So we write down the post here. And then the second thing we have to do is to clean up everything that is allocated on a per invocation basis. In this case, columns C, D, and E, they all belong to that one single invocation of sub1. So that means they are all going to be deallocated on line 6 when we return from the subroutine, when the subroutine concludes. So we're going to use strike out again, strike through, to mean that they are now deallocated. And when we're done, we get back to post. So when we get back to post, the only effect left is global variable 1, global var1, now has a value of 50. Everything that we did to the local variables and also the parameter is lost because those columns are now deallocated. So this is a quick demonstration of what we do with parameters. The next thing I want to illustrate is the limitations of a by-val parameter. So let's go ahead and look at a new algorithm here. So we'll say define sub swap. So this one is going to exchange the values of two parameters. So we'll say by-val first. Okay, so we have by-val x, by-val y, and we have a local variable called t. Okay, so this sequence is used very commonly to exchange the values of two things. Okay, and then outside of swap, we'll go ahead and specify. Well, we'll specify a main here, okay? And then we have local variable I, local variable j, and then we say I gets initialized to 16, and j gets initialized to negative 34, and then we invoke the subroutine. So we invoke the subroutine swap, and then we use I to specify x, j to specify y, and define sub, and overall we just say invoke main. And let me fix the indentation first, and then there are a few things I want to talk about in this code that is kind of important. There we go. All right, so the first thing I want to talk about in this particular pseudocode is in C and C++, everything starts with a subroutine called main. There's a hidden invoke main from outside of the program that you write, but it is always invoking main. So that means, in order to specify your first line of code, it is going to be the first line in main. So that's kind of a convention in C and C++, which is different from many of the other programming languages. Like most scripting languages will just pick up the first line outside of the definition of a subroutine to execute, but in C and C++, everything has to be inside the subroutine. So the only way you can specify where to start is to define a main subroutine. Okay, so that being said, okay, we'll go ahead and trace this code in our trace window here. So once again, we got line number, and this time we don't have any global variables because I and j are local to main, and then x and y are parameters of swap, and t is also a local variable of swap. So we don't have any global variables in this case. So pre is pretty easy to specify. There's nothing to say. And then we proceed to line 16. So remember, in the main, in the C and C++ program, we actually do not have line 16 to trace because that invocation is outside of a program. It is just implicit. But in this particular pseudocode environment, the invoke is actually explicit, so we're going to have to trace it. All right, so when we execute line 16, we have a return line number of post. Nothing really surprising. We have two local variables. One is I, starts with an unknown value. One is j, which also starts with an unknown value. Okay, so nothing really surprising here. And then we can go to the subroutine. The subroutine starts on line 12, which is highlighted. I gets a value of 16, and then on line 13, j gets a value of negative 34. Okay, so far so good. And then we invoke the subroutine called swap. So once again, on line 14, which is the line of the invocation, we have to allocate a return line number column, and that's going to be going back to line 15. And then we allocate one for parameter x, one for parameter y, and one for local variable t. Now, in the case of x, because I use the value of I to specify parameter x, we are basically copying this 16 over here. Okay? And in the case of y, we are using j to specify the value of j. We're using the value of j to specify parameter y, so we're copying negative 34 over here. So one really important thing is do not write I here and do not write j here, because whatever the value or whatever the expression is, in other words, this thing here, okay, oops, right here, this could be an expression. Instead of just I, it can be I plus something, or the best way to see this is, what if it's an expression of I plus a 0? Well, then it's really the same thing as I, isn't it? But that's also why we do not write down just I over here, because we have to evaluate the expression, and then we write down the value after the evaluation and put it into this column. So that part is kind of important. All right, so now that we have these columns allocated, t is an local variable, so that means it always starts with an unknown value. The question mark corresponding to a local variable is really important. Okay, if someone misses this part, I will take points off, because that's a very important concept to remember. After line 14, we get into the swap subroutine starting on line 5. The swap subroutine is not complicated at all. It is just really a whole, it's a sequence of 3 assignment statements. On line 5, we copy x to t. So we copy the value of 15. What is it, 16? It's 16 to t. Okay, so t is now 16. On line 6, we copy y to x. So we copy negative 34 to overwrite the 16, like so. And then on line 7, we copy the local variable t over y. So local variable t has a value of 16, and we use it to overwrite parameter y. So now parameter y has a value of 16. So this illustrates one thing that's kind of important. When you have a bi-val parameter, it is really just like a local variable. You can change it as you execute the code in the subroutine. So by the time we get to line 8, we actually have seen the exchanging of the value. X started with value 16, it is now negative 34, and y started with a value of negative 34, and now it is 16. So the exchange did happen correctly, successfully. But the thing is, they do not affect local variables I and j of main, which is kind of what I want to do. So by the time we get to line 8, when we end the subroutine, the return line number indicates we have to go back to line 15, not really surprising, and then we have to deallocate these 3 columns over here. And now we're back to line 15. Line 15 itself doesn't really do anything, so we go back to post because of the return line number, and then we deallocate these things. All right, and then we just use a strike through here, and this program is now finished. But the bottom line is, I want the swap subroutine to exchange local variables I and j of main, and that was not successful because I was using bi-val parameters. So, well, if that is not working, what are we going to do? So what we'll do is we're going to copy this program to a new sheet here, and this time we'll change just a little bit. Instead of using bi-val, I'm going to say these are by ref, which is the short abbreviation of by reference. So now x and y are passed by reference. And when you, in this class, okay, when you specify something to be passed by reference, we also have to change the arrows. And there's one extra requirement. When something is passed by reference, it can no longer be just an expression. It has to be something that can store a value. And then we change the arrow to a double-sided arrow, like so. Okay. So now we have made all the necessary syntactical change. So it's time to look at the behavior of this code and see how it is going to change. So we go back to the trace side, and then we have line number, usual. Nothing to specify about the precondition. So a by reference parameter is really a parameter, just like a other parameter. It does not exist until the invocation happens. And we start with line 16, same stuff as before. Okay, return line number, local variable I, local variable j. All the local variables start with unknown values, and then the return line number is post. So nothing about this really has changed. And then on line 12, we initialize I to 16. On line 13, we initialize j to -34. That has not changed either. But the next line has changed because the mechanism of passing a parameter by value is very different from the mechanism of passing a parameter by reference. So on line 14, the one part that hasn't changed is the return line number. We're still returning to line 15. That part has not changed. Okay. And the other part that still has not changed is each parameter and each local variable has its own column. So x has a column, y has a column, t has a column. T as a local variable is the same as before. It starts with an unknown value. That has not changed. But x and y have changed. In this case, because we are passing by reference, x becomes a specification of where do I go to find the actual thing that the by ref parameter is referring to. So when we say a parameter is passed by reference, it is basically saying the parameter itself is a reference to something else. Okay. So in the past, I use AKA, also known as, but in this class, I think I'm going to start to use refers to, which is kind of longer, but this refers to whatever column I is in. So because I is in column C, this refers to column C. And then Y is referring to whatever column J belongs to. So this is referring to column D in this case. It takes a little bit more space to write refers to. If we want to, maybe we can just kind of abbreviate this. Okay, so we can say refers to column C, and this one refers to column D. So I'm changing the way I specify it right here because it is not a good thing if it takes up too much space. There we go. So x refers to column C, y refers to column D, t is a local variable starting with an unknown value, just like before. Okay, so now when we get to line 12, what are we going to do? Well, it's not line 12, we're going to line 5. Sorry, there we go. So when we get to line 5, the right hand side is x. We go to the column x. When we go to the column that has a name of x, it says, oh, don't ask me, refer to column C. So now we refer to column C and it has a value of 16. So that means the right hand side of line 5 is 16. And as a result, t is updated to 16. Okay, so t is, we do not write down t as refer to column C because when we reference a parameter that is passed by reference, we are actually referring to the value of the column being referred to and not the reference itself. So that's why t is not getting reference to column C. It is actually getting the value in column C. So that concept is really important. We go to line 6, kind of the same thing. The right hand side of line 6 is y, so we go to the column that is labeled y. It says refer to column D, and that means refer to the value of column D, which is -34. So now the big question is, where am I going to store -34? Because the left hand side of line 6 is x. X says refer to column C, so when we store, when a pass by reference parameter is on the left hand side, we update the column that is being referred to. So column C is the one that is being changed to negative 34. So this is also important. And then we get to line 7. Line 7 says use whatever t, which is a local variable, has, which is the value of 16, and use it to change y. What is y? Y says refer to column D. So when we're changing, we're changing the column that is being referred to. So that means we're changing column D in this case to line 16. So the important part is do not change. If a parameter is passed by reference, it should never be changed in the subroutine. So x and y should not get any changes, throughout these cells here. Okay, but instead, the column that they refer to, whatever x is referring to column C. So column C is the one that is being referred to and possibly changed. Y is referring to column D, so that's why column D is the one that is potentially changed. So now we get to line 8. It's time to clean up and go back to the caller. So we use the return line number to go back to line 15, and then we deallocate all the columns the same way as before. So all of these columns are now deallocated. Which means, oh, we have just lost the reference to column C. We have also just lost the reference to column D. But because the changes were performed to column C and D while we were in the subroutine swap, that's why you can see column C, which is local variable I of main, is actually changed. And then column D, which is local variable J of main, is also changed. So by the time we get to line 15, which is in main, the result is local variables I and J are changed at this time, as opposed to the previous time when we used by val parameters, and nothing happened to local variables I and J in that case. So when we get to line 15, we do the same thing. Okay, we look up the return line number. It tells us to go to post, and then we deallocate every single column that main has. So we deallocate all of these here, and then we use strike through to indicate that. So now we are pretty much done with this new swap subroutine. So if you compare and contrast the two traces, okay, if you compare and contrast the trace with by val parameter versus the trace with by ref parameter, you can see, when you're passing by value, you're really just copying whatever the value is to the parameter. But when you're passing by reference, you are actually saying, oh, I was in column C, so now X is a reference to column C. J is in column D, so now Y is a reference to column D. That is the main difference between passing by value versus passing by reference. The other part that is, as a result of this, when we change a parameter that is passed by value, it really is just a column of the parameter itself getting changed when it's passed by value. But when it is passed by reference, it is not the column of the parameter that is getting changed. It is the column that is referred to by the parameter that is getting changed. So that is the other change, the big change of passing by value versus passing by reference. Syntactically speaking, the change is fairly minor, but it is kind of important to notice as well. So when you look at the syntactical change, we are just saying by val to indicate a parameter is passed by value, and we use by ref to indicate a parameter is passed by reference. We also use arrows, different arrows. When something is passed by value, we use a right arrow, and then whatever is to the left of the right arrow can be any expression. It can be a gigantic expression. When we pass by reference, we use a double-sided arrow to basically say whatever happens to the parameter happens to whatever is used to specify the parameter. And then whatever is used to specify the parameter has to be something that can change over time. So it has to be a global variable or a local variable or a parameter. So all of those can be used, but you cannot use a general expression like I plus 0 or I times 1. That would not work in the case of passed by reference. So this is a explanation of passing by value versus passing by reference. And if you go back to the notes, it is all here, in section 3. The only change that I have made in this case to section 3 is when I pass by reference, instead of using AKA, also known as, or using this notation, I basically, because a spreadsheet has the ability to refer to a column name, so in the spreadsheet I just say refer to column C and refer to column D, because it is much more clear this way than using the other way. Because when I made this table, there's no column designation, and that makes it impossible to specify that X as a pass by reference parameter is referring to main var. All right, so there's a little bit of change in terms of notation. So use the notation that I use in this lecture, or in this YouTube lecture, as the reference material. Okay, I'm going to take a short break now, and then when I come back, we'll continue to talk about the concept of a return value. So we'll go ahead and do that later.